So, we have started discussing about the internet protocol. So, the IP layer, we have already started discussing about the header. So, today what we will try to do in that header, some portion we have already we have discussed, some portion is left, especially the addressing part and the fragmentation part. So, that is something we will be discussing next. Okay. So, let us try to see. So, this was the header in the last class we were discussing about. Okay. So, in that header, if you see in the second this one row, you have a ID. Okay. So, basically you have a ID of 16 bit, and then there are two fields, one particular bit is not being used. So, that is left for future use. Then you have a 1 bit field of DF. So, that is called don't fragment. Then there is another bit called MF, which is more fragment, and then there is something called fragmentation offset. Okay. So, this is 16 bit, 1 bit, these two are flags, and this is 13 bits. Okay. So, let us try to see how it operates. So, what we are talking about is something like this, that a particular router, so this is a router, intermediate router, it gets a long IP packet. It knows that from the routing table it has decided that I have to forward it to next router. This link physical layer is not very reliable. So, he has to make the packet size smaller, or it might have other restriction also. Because of that also there might be a smaller packet size, because this might operate on other network which has a restriction of smaller packet. Okay. So, this might also happen. So, if that happens, then he has to actually, there is a maximum size of packet length that can go through this link. Then he has to actually fragment those packets of that size. But the problem is, whenever this particular packet he fragments, it will be generating multiple small fragments. But now these fragments, when they come over here, these fragments has to be again regrouped with proper order. So, this is something, whenever you do fragmentation, this is something which has to be facilitated. So, that facilitation is done by these bits. So, what happens? So, basically any time you do fragmentation, it might happen that he has multiple packets, okay, which are coming one after another, and he has to definitely fragment all of them. Now, a fragment from here and a first fragment from here, they might be confused. So, he might jumble up these two things, because these fragments might wait arbitrarily longer time in his, because it is a store and forward. So, you first store them. So, multiple packets might be stored, all their fragments might be stored. Now, these fragments, if they are not properly numbered and identified, they might get jumbled up. So, therefore, first I need to have an ID of which packet I am fragmenting. So, every packet that you will be fragmenting, that has a unique ID that will be given over here with 16 bit. This 16 bit provides a unique ID for a particular packet which will be fragmented. Okay. So, this is something you will be always doing. So, you provide a identification number of that particular packet. So, remember, you might be thinking that who will be providing this ID. So, this router can itself provide that ID, no problem in that, because, or it might be also given by the source, that is also possible, that source can start putting ID, because you might be thinking that this ID might get confused. Suppose this router is getting packet from one source and another source is also coming. Now, these two sources, if they give same ID to two packets, will there be a problem? No, there will not be, because there are IP headers, means there is IP header where this source ID and destination also is there. So, if I combine this source ID, destination ID and ID, these three things, that will be unique for a particular source destination combination. So, basically for every source destination, if every packet I keep on giving ID one after another, no problem in that. If they are, means they are identified, so they can be fragmented accordingly. Same ID has to be put in all subsequent IP packets. So, whenever you fragment, all subsequent packets must have IP headers, because otherwise you will not be able to do routing. So, therefore, those same ID can be copied. So, basically this has a source ID, let us say S1, destination ID D1, and this has I1 as the ID. This will have again S1, D1, and this will be I2. So, subsequently all these packets, here you will be putting these 3 combination and put the IP header. So, all these small fragment will have their own IP header, second fragment also will have their own IP header. So, you keep on doing that. So, entire packet you fragment into multiple fragments and you add corresponding IP header, which is identified by unique identifier, source and destination ID, of course. So, therefore, there is no possibility that anything coming from other source and other destination that will be getting jumbled up with this ID, because they will have, they might have, because each source will be uniquely generating ID. So, one after another in a sequential manner. So, when they generate I1 followed by I2 followed by I3, this guy also putting I1 followed by I2 I3, even if they actually coexist in the same router, they will not be confused, because they have different source ID, destination ID. Okay. So, fragmentation wise I will have never have problem, I will be able to identify which one are for this source, this destination. I will take all of them together and then I will try to see who has I1, who has I2, then accordingly I can actually manage them. Now, the problem is what is happening, now all these packets now will have same this specification S1, D1, I1, but they might get jumbled up. I can put this in first, this in second, this in fourth, this in third. So, this will jumble up the whole thing. So, I need to identify their order also inside the fragment, within one particular packet inside the fragments, among those fragments what is their relative order. So, that is where this fragment offset comes into picture. So, fragment offset specifies where from this particular fragment starts in the sequence. Okay. So, whether this is the 4th fragment, this is the 5th fragment or this is the 6th fragment. So, it will be able to specify that accordingly. Seeing those things, okay, you will be able to join these data together. So, fragment offset actually tells you that. And what are these flags? This flag is having something called don't fragment and more fragment. Okay. If you fragment, there is a problem. What is the problem? If you fragment the packets, okay, packets will be forwarded very nicely. So, wherever one router does the fragmentation, so now onwards the packet has been fragmented. So, these small packets will be delivered through the next router to next router to next router, finally it will reach to the destination. Now, the problem is if the destination cannot defragment the packet. So, basically if they are fragmented, then you have to identify these things, that okay, which source, which destination and which ID, accordingly you have to club them. After clubbing them, you have to see those fragment offset, accordingly you have to rearrange them and then construct the whole packet, stripping off all the corresponding IP header and then deliver it to the next transport layer. So, doing these things, sometimes some destination might not have this facility. Therefore, source will be knowing about that. If he is transmitting packet to the destination, he will also know the capability of the destination. How he knows? You will understand that from our description of transport layer protocol, because transport layer is end to end. They can first talk to the destination and construct a connection knowing the capability of the destination. So, if that is the case, because source knows it, so he might set this flag. If he set this flag, that means if he puts 1 into that, none of the router can, if he sees that that flag has been set, he will not be able to fragment that packet. Now, you might be asking what can he do, because this is a wireless link. If he do not fragment that packet, most of the packet will be lost, they will be erroneous, and then he might have to multiple times he might have to retransmit and never it will go through. Okay. So, what he can do, if he sees that that link requires, this is the local link which requires lower packet size, but the packet that has arrived, that requires a means that is requesting that do not fragment my packet, then you actually search for other routes. Do not take this route, this might be a shortest route. If you go via this, the destination might be reached in smaller number of hops or with lower delay, but you can always redirect it into some other router and he might redirect and go through a longer path to the destination, but you do not have to fragment it. So, basically you choose those paths which are more reliable, where fragmentation is not required. So, you can always do that. So, if the do not fragment bit is set, then you can do these things. What is this more fragment? So, this is another thing which tells you one by one whether you have some more fragments which has to be appended. So, this helps the destination to actually defragment the packet. So, from packet, suppose you have constructed these fragments. So, this is my fragment 1, fragment 2, fragment 3, fragment 4, fragment 5 and fragment 6. So, first 5 fragments you will be setting this more fragment to 1. That means, in those fragments, whenever that packet is arrived, you also know there are some more fragments which are waiting. So, you have to actually wait for other fragments. Only when you receive the last one, that is where the more fragment bit will be not set, that means it will be 0. So, then you know that okay, I have reached to the final fragment. So, that should be it, and I have got the whole fragments. Now, I can join the packets together. So, like this, as you can see, this actually facilitates the entire network, all the associated routers and the destination along with what source specifies. This helps the entire network to handle the packets in between. User do not have to care whether in between he has a particular means link where it is wireless, where it is not that reliable. I might have to make smaller packets. So, all those things user do not have to care. User can just do these things knowing the destination, what is his capability. User can just deliver this packet, and then IP layer, it does this whole fragmentation part to manage the data delivery smoothly. Okay. So, this is one way of appreciating how header specification and associated protocol, that means associated algorithm that will be running, that together helps source, destination and in between nodes, helps some particular task of networking to be performed. And that is exactly what is happening over here. As you can see over here, we have seen that if you have to fragment, then how do you fragment it? What are the specifications that you give into the fragmentation, so that the other side, without the intervention of the source, they can defragment the packet and generate the original packet. And this has nothing to do with the data, data remains intact, you just deliver it smoothly according to your network need. So, this is a network layer task, this has nothing to do with actual data. Actual data will remain intact, whether you fragment it, finally you will have to exactly do the opposite things to defragment it and make the intact, means packet intact, so that you can deliver it to the application layer. So, this is something you could understand. Okay. So, we have discussed about fragmentation. Next, we thought of discussing about this IDs, which are the unique IP addresses. Okay. So, as you can see, that is 32-bit address. This 32-bit address generally is subdivided into 4 8-bit subsection. Okay. So, this is 8-bit. With 8-bit, how many representation you can do? So, now we can see a decimal, means whatever representation we will be having, we can convert that into binary to decimal, these things. So, you might have a particular realization as 0 0. So, it will be 8-bit 0 0, let us say 0 1 0 0, 1 2 3 4 5 6 7 8. Okay. So, if you see, this is actually, if you take the corresponding, means decimal representation, accordingly you will be able to put the decimal representation. Okay. So, what will be the overall decimal representation that can be happening with this 8 bit? So, if all 0 it will be 0, if all 1 it will be 255, right, with 8 bit. So, 0 to 255 some representation, unique representation you will be able to build up. Okay. So, what they do, each one will have this 0 to 255, each 8 bit, and you put them just for representation, thus IP addresses are put in this with dot decimal format. So, basically I can write 192.15.6.1. That means it is a 32 bit. The first, this one has a binary representation equivalent to decimal 192. Second 8 bit has a binary representation equivalent to decimal 15. Third one 6 and fourth one 1, so on. So, basically if I give that, accordingly you will be able to always calculate the equivalent binary 32 bit representation, but for our understanding it is generally represented, IP addresses are generally represented, you might have seen that this kind of IP representation, IP address representation, you might have seen that. Okay. So, this is how IP addresses are being represented. Okay. It will be always this with 3 dots and 4 decimal value, they will be ranging from 0 to 255. Okay. And whatever unique values you will be providing over here, that should be the unique ID. So, each packet, as you have seen, that it will have a particular source ID and a destination ID. Where you want to send that ID you need to know. So, basically whenever you are sending a packet, you of course you will be knowing your own IP address, and that should be unique globally. So, you must have a unique ID, nobody else is sharing that ID, and your targeted destination, his IP address you need to know. Okay. So, whenever you are connecting, if you are doing let us say some of the older application layer protocols like FTP, or let us say you do means this kind of means remote login and all those things, always you will be seeing that suppose server you are trying to log in. So, you always give the IP address of the server, that is exactly what you do. Okay. And generally what we do, we give the IP address of the server, along with we also give a port ID, sometimes we write 8080 or something like that. Okay. So, you might be seeing that whenever you are doing FTP or you are doing some other remote login. So, you generally put this IP address and a port. This port is the TCP port, we will talk about that when we will be discussing about TCP, but generally this is what you will have to specify. So, basically the transport layer and IP layer, both the things you will have to give, then only you can connect to the remote this one. So, destination you want to connect, then you have to specify his unique ID. If you do not know the ID, then you cannot connect. You might be asking, then how do we do not know the IP of whenever we do this HTTP search, okay, or HTTP, suppose we log into Google page, we do searching, we do all kinds of things. There we do not specify IP addresses, then how this particular things, this networking goes on, that has another thing. Even though you do not specify the IP addresses, you specify something else. Suppose whenever you have to go to a Google page, you have to type that www.google. If you are in India, suppose you write co.in. As you can see, this is also typed with dot. So, almost similar to IP address, and this is what happens. We will later on we will see that there are, means instead of having these numbers, people have actually come up with corresponding names, so that people can remember those things. So, and there is something called DNS or domain name server, and then this DNS enquiry and all those things, from which we can actually adjust this IP addresses, or from the name we will be able to find the corresponding IP addresses. So, whenever we type this, it has a corresponding IP address. So, do not think that IP addresses we do not require. So, whatever in your HTTP this one you are typing, it has a corresponding IP address. So, you are actually whatever you are typing, you are accordingly, if you write for Facebook, if you write for let us say Twitter, or let us say whatever the site, YouTube, always they will have a underlying IP address. So, whatever name you give, from that a corresponding unique IP address is there, it will connect to that server only. Okay. So, sometimes they might have multiple server, okay, and then you go to a particular server and then it distributes it locally internally. So, that you might not understand, but generally it is always the unique IP ID of the other server, okay, that you are, or your targeted destination. This will be always happening. So, IP address is always like this, destination ID you will have to specify, otherwise no communication can go through. Okay. So, that is why always every header, even if you fragment them, this IDs should be there, who is the source and who is the destination, this should be always specified. This 32 bit will always be there. Now, because with 32 bit, how many machines you can construct, or how many machines you can have globally? 2 to the power 32 at max. This is a very big number, of course, but still, because these days almost every machine is having their own ID, like we are going to the era of internet of everything, right. Internet of things we have already seen, IoT, that means everything, every small devices, starting from your coffee maker to your refrigerator to your television, everybody will be connected to internet and they will have their own ID. Okay. There will be thousands of sensors installed everywhere, and all those sensors will have their IP address. So, if you have to give this many unique ID, then that is 2 to the 32 is not good enough. So, that is why IP, from IP version 4 we have come to IP version 6, where this IP addresses are of 128 bits. Okay. So, with this we will be having a huge possibility of 2 to the power 128 unique IDs. So, that will be billions of this one, and that will cover all the devices that you can think of right now probably. So, that is why probably means that was the major drive going from IPv4 to V6, because IPv4 was not capable of handling that many global ID generation. Okay. So, remember there are authorities which actually reserves the right to distribute IP address, because it has to be globally unique. So, not anybody can locally decide, okay, I will take this IP address. You cannot with your own whim decide that I must have this IP address, that you cannot do. Your organization or your service provider, whomever you are taking the service from, they must reserve those IP address from the body authority who is responsible for distributing IP addresses. Okay. So, that you have to do, first reserve those things, and then that has to be distributed among those users. So, this is very essential, and you have to keep in mind that that is what happens for IP addresses. These are very precious, you have to actually means they are costly also, you have to pay for those addresses. Whatever you will be blocking, you cannot just like that as many addresses you want, you cannot block them, because whenever you are taking these addresses, those addresses are lost, they cannot be distributed. So, less number of devices can now request for IP addresses, as you can see. So, that is why there is a crunch of IP addresses, and as we have talked about that already IPv6 has come towards the rescue, that it will come up with bigger number of IP address pool, because it has increased the IP address field. But before going over there, as we have also talked about, that networking is all about adaptation and backward compatibility. So, there you will see, we will talk about those solutions also, you will see there are solutions where with restricted number of IP address, how you can handle them. Okay. So, we will talk about this, there is a protocol called DHCP, dynamic host configuration protocol. We will also talk about NAT. These are all part of how you can actually with restricted number of IP addresses, how you can still manage it. Sometimes you can reuse it, but in a very different fashion. We will talk about that later with NAT probably, whenever we will be talking about this NAT, we will be talking about that. So, these are the things which will be happening. Even though we have restricted number of IP addresses, there are possibilities of handling it in a more intelligent fashion, and you will also see that how means allocating IP addresses to a particular area actually helps in doing the routing decision, or helps making this routing decision little bit easier. So, next class we will be discussing about that, that is more of subnetting, how it is being done. So, how do you create subnet, how do you create subnet mask to facilitate router to do routing in a faster manner. So, all those things we will see, it is all about this handling these addresses. So, that will be our next target. We will see how IP address has been classified, it has also been classified, and how they can be handled in a better manner. So, this is something which we will be discussing in the next class. Thank you.